What killed the pipeline? It's a question that sounds simple, but the answer, well, it's anything but. We're about to dive into the anatomy of a disaster, piecing together clues that were literally buried deep underground. Let's figure out what really happened here.
So let's set the scene. October 22nd, 2020. A gas pipeline in Thailand just explodes. We're talking about a massive, high-pressure rupture that triggered a devastating fire. This wasn't just any accident. It ended up being the worst of its kind in the country's entire history.
Okay, so after the dust settles, what's next? An independent investigation was launched to answer that one critical question that's on everyone's mind. Why? How does something like this even happen?
So, the investigation begins. But you can't just look at the wreckage to find the answers. The real clues were buried in time. The investigators needed a way to rewind the clock. And they did it using something pretty amazing, basically a digital crash test.
This digital crash test is officially called the finite element method. Now that sounds complicated, but the idea is brilliant. To really understand how something complex breaks, you can't just look at the whole thing. So you break it down digitally into millions of tiny pieces. Then you use a supercomputer to see how every single one of those little pieces behaves under immense pressure. It lets you see the invisible, the stress building up year after year.
So how'd they actually run this thing? Well, step one, you build a perfect 3D model of the pipeline and all the ground around it. Step two, you start adding the real-world pressure. In this case, that was the weight of a landfill that was piled on top over 6 whole years. Step three, you add even more pressure from the heavy machinery that was working up there. And finally, step four, you measure the stress. You get to see exactly what all that weight was doing to that pipe.
And right away, the simulation pointed to a prime suspect. And it wasn't some sudden, dramatic event. No, this was a slow, silent killer that had been at work for years. The shifting ground itself.
You see, the ground in that area is really soft clay. So as more and more landfill got piled on top, the ground just sank, and it took the pipeline with it. The simulation showed that after just 1 year, the pipe had already sunk 14 millimeters. 3 years in, it was down 37 millimeters. And by year 6, a whopping 101 millimeters. That is almost 4 inches. Just try to imagine bending a solid steel pipe that much. The strain is just enormous.
And all that bending put incredible stress on the pipe. Think of it like a ticking clock. After just 1 year, the stress on the pipe was already at 68% of its safety limit. Fast forward to year 6, and it's at 97%. It was literally on the verge of breaking. In fact, the simulation projected that if nothing changed, the stress would have eventually hit 131% of the safety limit. Failure wasn't just possible at that point. It was basically a guarantee.
So, there you have it. Case closed, right? The shifting ground did it. Well, not so fast. The ground pressure alone pushed the pipe to its absolute limit, for sure. But the simulation showed it wasn't the only culprit. There was something else at play, an accomplice.
So who's our second suspect? Well, this time, investigators had to look inside the pipe itself. They found a fatal flaw, a problem that had been there from the very beginning, long before the ground ever started to shift. It all comes down to the welds. You see, in a perfect world, the pipe sections are lined up perfectly, so stress flows through them nice and evenly. But on site, they found a seriously flawed weld, known as W9. Here, the sections were misaligned. That little misalignment creates a massive weak point, a little internal ledge that basically acts like a hook, catching and concentrating all that external stress in one tiny, vulnerable spot. It's a recipe for disaster.
And you don't have to take my word for it. The official engineering report says it right there, that this misaligned connection becomes a stress concentration point and the perfect starting point of fatigue damage. So you have this constant, immense pressure from the ground, all focused on this one single weak spot, day in, day out, for 6 years. It was the pipeline's Achilles heel, just waiting to fail.
So, now we have the verdict. And it's clear it wasn't just one thing or the other. It was a perfect storm. Factor one, you had this immense, continuous pressure from the shifting earth above. Just a slow, relentless squeeze,
pushing that pipe to its absolute breaking point.
And factor 2? You had that critical flaw, that pre-existing weak spot in a single weld from when the pipe was first built. The external pressure found the internal weakness, and that combination, that's what killed the pipeline.
Okay, so now we know why it happened. But the story doesn't end there. The most important part of this whole investigation is what we do with this knowledge. How do we prevent the next one? It's all about moving from reaction to prevention.
First up, new rules for construction. The big takeaway here is that there's no one-size-fits-all safe distance. It all depends on the soil. As you can see, the thicker that layer of soft clay is, the bigger the safety buffer you need. If the clay is over 20 meters deep, any construction needs to be at least 6.5 meters away. It's a simple, smart way to prevent that dangerous ground settlement from the start.
And second, they came up with a new early warning system. It's a 3-step process. Step 1 is the alert level. If sensors detect even a little bit of bending in the pipe, you ramp up monitoring. Step 2 is the alarm level. If that bending gets worse, you have to report it to the authorities and, crucially, reduce the pressure in the pipe. And finally, step 3 is action. If the bending hits a critical point, you shut off the gas flow immediately until it's fixed. This is a total game changer.
Which really brings us to the big, final question, doesn't it? So much of our most critical infrastructure is buried underground, just like this pipeline. But should its safety be buried too? This disaster didn't happen in a flash. It was a slow-motion failure over 6 long years, completely invisible from the surface. And it's a huge reminder that out of sight, out of mind is a really dangerous way to think about these vital systems. The only way to keep them safe is to make the invisible visible.